Metallurgy. The science and technology regarding the extraction of metals from ores and their purification for the use is called metallurgy. Occurrence of metals. Metals occur in the nature in the free state and in the combined state. Reactive metals are found in the combined state as their salts such as oxides, carbonates, sulfides, and nitrates. Unreactive metals like silver, gold, platinum that are not affected by air, water, and other natural factors generally occur in the free state. The compounds of metals that occur in nature along with other impurities are called minerals. Minerals from which metals can be separated economically are called ores. Along with metal compounds, ores also contain certain impurities like soil, sand, rocky substances, earthy particles, etc. These impurities are called gann. Metals can be extracted from their ores by means of various methods of separation. After the ore is mined, it has to be converted to the pure metal. The process of obtaining a metal from its ore is called extraction. The processes which involve the extraction of metals in the pure form from their ores are included in metallurgy. Minerals are first taken out from the ore mines. Then, the gann is separated from the ore by various methods. The ores are then carried to a place where metals are produced. Here, metals are extracted in the pure form. The metals are further purified by using different methods of purification. All these processes together are called metallurgy. Basic principles of metallurgy. Let us understand the different stages of the extraction of a pure metal from the ore. Concentration of ores. The process of separating the gann from the ore is called concentration of the ore. This process increases the concentration of the desired metal. The method used for concentration depends upon the physical properties of the metals present in the ore and of the gann present in the ore. The method also depends upon the reactivity of the metal. Let us familiarize ourselves with some general methods of concentration of ores. Separation based on gravitation. In this method, the heavy particles of the ores are separated from the light particles of the gann by the method based on gravitation. Let us understand some methods based on this principle. Wilfley table method. The Wilfley table is an inclined table made by fixing narrow and thin wooden wedges or blocks. The table is continuously vibrating. The powdered ore obtained from lumps of ore using a ball mill is poured on the table. Simultaneously, a stream of water is also released from the upper side. As a result, lighter gann particles are carried away along with the flowing water, while the heavier particles which contain higher proportion of minerals and less proportion of gann that are blocked by the wooden wedges are collected between the slits. Hydraulic separation method. This method works on the principle of the working of a mill. There is a tapering vessel similar to the one used in a grinding mill. This tapering vessel or tank has an inlet for water on the lower side and an outlet for gann on the upper side. Finely ground ore is released into the tank. A fast stream of water is introduced in the tank from the lower side. The gann particles, being lighter, flow along with the water from the outlet, while heavy particles are collected at the bottom in the lower side of the tank. Since particles of the same size are separated as per their weight with the help of water, it can be said that this method is based on the law of gravitation. Let us proceed to the next method of concentration of the ore, which is based on the magnetic property of substances. Magnetic separation method. This separation technique requires an electromagnetic machine. The machine consists of two types of rollers and a conveyor belt which moves continuously around them. One of the rollers is non-magnetic, while the other is electromagnetic. The conveyor belt, which is moving around the rollers, is made up of a non-magnetic material like leather or brass. The powdered ore is poured at the end of the conveyor belt, which is on the side of the non-magnetic roller. There are two collector vessels placed below the magnetic rollers. The particles of the ore, which are non-magnetic in nature, are not attracted towards the magnetic roller. They are therefore carried further along the belt and are collected in the collector vessel, which is away from the magnetic roller. The particles of the magnetic ingredients of the ore stick to the magnetic roller and fall in the collector vessel near the belt. This technique is used to separate components of a mixture which are magnetic in nature. By this technique, magnetic particles can be separated from the non-magnetic particles of the ore. Cassiterite is a tin ore. It contains the magnetic ingredient ferrous tungstate, that is FeWO4, and the non-magnetic ingredient stannic oxide, that is SnO2. This ore can be separated by the electromagnetic method. The next method is the froth flotation method. Froth flotation method. The froth flotation method is based on the hydrophilic, that is, the water-loving properties, and the hydrophobic, that is, water-repelling properties of the particles. This method is generally used for sulfide ores. The metal sulfide particles get wet mainly with oil due to their hydrophobic properties, while the gangue particles get wet mainly due to their hydrophilic properties. Let us understand the method in detail. First, the finely ground ore is put in a big tank containing lot of water. Then, a certain vegetable oil like pine oil or eucalyptus oil is put in water for the formation of froth. Pressurized air is then blown through the water. In the center of the tank, there is an agitator which is constantly rotating around its central axis. The blown air causes bubbles in the mixture. The agitation causes formation of foam due to the oil, water, and air bubbles. This foam rises to the surface of water and floats. That is the reason the method is called froth flotation method. Certain sulfide ore particles preferentially get wet by oil and hence float with the foam on water. Sulfide ores like zinc blende, that is ZNS, and copper pyrite, that is CuFeS2, are concentrated by this method. In our day-to-day life too, we come across certain objects which show preferential wetting. Have you observed the colocasia leaves? The colocasia leaves are waterproof. The leaves have a waxy coat due to which water does not remain on the leaves. You may have also observed that wax cannot be wetted by water, but salt or soap can be easily wetted with water. Let us now proceed to the next method. Leaching method. The leaching method is generally the first step in the extraction process of metals like gold, silver, and aluminium from their ores. In this method, the ore is soaked in a certain solution for a long time. A chemical reaction takes place due to which the ore dissolves in the solution. The GaN does not react with the solution, hence it does not dissolve in it. In this way, it is separated from the ore. Bauxite, which is the aluminium ore, is concentrated by the method of leaching. In this process, bauxite is soaked in aqueous sodium hydroxide or aqueous sodium carbonate. The main ingredient of the ore, that is, alumina, dissolves in it while the GaN does not dissolve. Thus, the ore is concentrated. The processes used for the extraction of metals depend upon their reactivity. Now, let us first understand the extraction of reactive metals. Extraction of reactive metals. Metals placed on the top of the reactivity series are highly reactive. For example, potassium, sodium, and aluminium. Reactive metals have a large capacity to form cations by losing electrons present in their outermost shell. Reactive metals react vigorously with dilute acids to liberate hydrogen gas. Highly reactive metals burn by reacting with oxygen from the air even at room temperature. Reactive metals usually occur in the form of their oxides or chlorides. The process of electrolytic reduction is used to obtain the metal from the metal oxide or the metal chloride. The metals, sodium, calcium, and magnesium are obtained by the electrolysis of their molten chlorides. In this process, the pure metal is obtained at the cathode and chlorine gas is obtained at the anode. For example, in the electrolysis of molten sodium chloride, sodium metal is obtained at the cathode and chlorine gas at the anode. In the electrolysis of molten magnesium chloride, magnesium metal is obtained at the cathode and chlorine gas is obtained at the anode. In the electrolysis of molten calcium chloride, calcium metal is obtained at the cathode and chlorine gas is obtained at the anode. Similarly, aluminium is also obtained by the process of electrolytic reduction of its oxide. Let us first understand how the metal aluminium is extracted from its ore, bauxite. Extraction of aluminium. Aluminium is a silvery white metal. Its symbol is Al and it belongs to group 13 of the periodic table. Its atomic number is 13 with electronic configuration 2,8,3. Aluminium shows a fixed valency of 3 in its compounds. Aluminium is a reactive metal. It occurs as an oxide in nature. Aluminium is the third highly abundant element in the Earth's crust after oxygen and silicon. The most important and common ore of aluminium is bauxite, which is hydrated aluminium oxide, that is Al2O3 NH2O. The ore contains about 30 to 70% of aluminium oxide. The remaining portion is gangue, which is made up of sand, that is silicon dioxide, and iron oxide. The extraction of aluminium involves two steps. The first step is the concentration of the ore, and the second step is the electrolytic reduction of pure alumina. Step 1. Concentration of the ore. Bauxite is the main ore of aluminium. It contains the impurities silicon dioxide, that is SiO2, ferric oxide, that is Fe2O3, and titanium oxide, that is TiO2. The concentration of the ore involves the separation of these impurities by leaching and conversion of bauxite to pure aluminium oxide or alumina. This process used here is called Bayer's process or Hall's process. In the Bayer's method, the bauxite ore is first crushed in a ball mill and is leached by heating with concentrated sodium hydroxide or caustic soda under high pressure for about 2 to 8 hours and at a temperature of about 140 to 150 degrees Celsius. This process is carried out in a tank called a digester. Aluminium oxide of the bauxite ore is amphoteric in nature, that is, it can react with an acid as well as a base to form salt and water. It therefore reacts with aqueous sodium hydroxide and dissolves in it to form water-soluble sodium aluminate. This process is called leaching of bauxite by sodium hydroxide. Sand or silica present in the gangue also dissolves in aqueous sodium hydroxide to form water-soluble sodium silicate. Iron oxide in the gangue does not dissolve in aqueous sodium hydroxide. It is then separated by filtration. The filtrate now contains aqueous sodium aluminate and water-soluble sodium silicate. The filtrate is now diluted with water and then cooled to 50 degrees Celsius. At this stage, sodium aluminate gets hydrolyzed to form aluminium hydroxide. In the Hall's process, the ore is powdered and leached by heating with aqueous sodium carbonate to form water-soluble sodium aluminate. This process takes place in the digester. The impurities present in the ore do not dissolve in sodium carbonate. They are separated by filtration. The filtrate is warmed and neutralized by passing carbon dioxide gas through it. This results in the precipitation of aluminium hydroxide. Aluminium hydroxide, which is obtained by both the processes, is filtered, washed, dried, and ignited at about 1000 degrees Celsius to obtain pure aluminium oxide, which is also called alumina. This method is called calcination. The next step is the electrolytic reduction of alumina. Step 2. Electrolytic reduction of alumina. Electrolytic reduction or electrolysis is carried out in a large steel tank which has a graphite lining on the inner side. This lining acts as the cathode. There is a set of carbon rods or graphite rods dipped in the molten electrolyte, that is alumina, which act as anode. Pure alumina has a high melting point which is greater than 2000 degrees Celsius. In order to lower the melting point, pure alumina is mixed with molten cryolite, that is Na3Al(F6) and fluorspar, that is CaF2, and then melted in the steel tank. Thus, electrolysis can be carried out at about 1000 degrees Celsius. Now let us see the reactions taking place during the electrolysis of alumina. On passing an electric current, electrolysis of alumina takes place. During electrolysis, the negatively charged oxide ions are attracted to the anode. Here they lose electrons to form oxygen gas. The positive aluminium ions are attracted to the cathode. Here they gain electrons to form the molten aluminium metal. Molten aluminium is denser than the electrolyte, hence is collected at the bottom of the tank. It has to be removed from time to time. Oxygen gas liberated at the anode has a tendency to react with the carbon anode itself to form carbon dioxide gas. So the carbon anodes are gradually oxidized or consumed during the electrolysis, and therefore they have to be replaced from time to time. Now let us discuss the extraction of moderately reactive metals. Extraction of moderately reactive metals. Metals placed in the middle of the reactivity series, that is, zinc, iron, lead, are moderately reactive. These metals are usually present in the form of their sulfides or carbonates. It is easier to obtain a metal from its metal oxide by reduction than from its metal sulfides or metal carbonates. Therefore, metal sulfides or metal carbonates are first converted to metal oxides by processes like roasting or calcination. Roasting and calcination. In the method of roasting, the sulfide ore is heated strongly in the presence of excess of air to convert it into oxide. For example, zinc occurs in the form of zinc sulfide in its ore, zinc blende. Zinc sulfide, when heated strongly in the presence of air, can be converted to zinc oxide. Carbonate ores can be converted to metal oxides by a process known as calcination. In this method, the carbonate ore is heated strongly in the presence of limited supply of air. Zinc also occurs as zinc carbonate in its ore, calamine. Zinc carbonate, when heated strongly in the presence of limited supply of air, gets converted to zinc oxide. The metal oxide so obtained by calcination or roasting is reduced to zinc by reducing agents like carbon. Besides carbon, highly reactive metals like sodium, calcium, and aluminium are used as reducing agents to obtain the metal from the metal oxide. These metals can be used as they can displace the moderately reactive metal from its compound. For example, manganese metal is obtained from its oxide when it is ignited with aluminium powder. Here, aluminium acts as a reducing agent. In this reaction, aluminium is oxidized to aluminium oxide and manganese dioxide is reduced to manganese. It is an exothermic reaction and the metal manganese produced is in the molten state. This is also a displacement reaction in which manganese is displaced by aluminium. Another such type of reaction using aluminium as a reducing agent is the thermite reaction. Here, iron oxide is reduced by aluminium powder to produce the metal iron in the molten state. This property of reduction of aluminium is used in thermite welding for joining broken pieces of railway tracks. The molten iron formed from the reaction between iron oxide and aluminium is poured between the broken rails to weld or join them. Now let us discuss the extraction methods used for less reactive metals. Extraction of less reactive metals. Metals placed at the bottom of the reactivity series are the least reactive, for example, copper, silver, and gold. These metals can be extracted from their oxide or sulfide ore by just heating them in air. Copper is found as copper sulfide in its ore, copper glans. When the copper sulfide ore is heated in air, part of the copper sulfide is oxidized to copper oxide. Sulfur dioxide is also formed in the reaction. When the supply of air for heating is stopped, the copper dioxide formed earlier reacts with the copper sulfide to form copper metal and sulfur dioxide. Similarly, mercury is obtained from its ore, cinnabar. When the ore is heated in air, mercury sulfide is first converted to mercury oxide and sulfur dioxide. When this mercury oxide is further heated, it gets reduced to mercury. Metals obtained after reduction processes may contain impurities. The process of purifying impure metals is called refining. Refining of metals. The most widely used method of refining metals is electrolytic refining. In this process, The impure metal is connected at the positive terminal of the battery, and a thin strip of pure metal is connected at the negative terminal. The water-soluble salt of the metal to be refined is taken as the electrolyte. On passing an electric current, the impure metal dissolves from the anode and goes into the electrolyte. The metal from the electrolyte deposits on the cathode. The soluble impurities present in the impure metal go into the solution, whereas the insoluble impurities settle down at the bottom of the anode. In this way, the pure metal is produced at the cathode. What is meant by corrosion of metals? You must have observed that iron objects, if remain unused for some time, get rusted. This process is called corrosion. Let us know more about corrosion of metals.